Fix workshop, we are going to try and compress the most important parts of that into one day. We'll be done by 5 o'clock. And the plan today is, one, to introduce you to the hardware, to introduce you to the software, and then for you all to do one case by yourselves, that is of one Sawbone model, where you will apply the struts, you'll take the pictures, which is like doing the X-rays, upload it into the software, and get the correction. Now, all of you all, I take it, are well versed with the Elizarov. So, and that's the bottom point. The def fix is not something different from the Elizarov. The def fix only replaces the hinges that we use for deformity correction. The issue with Elizarov is that you need to sometimes change the hardware when you want to do different manipulations. So Elizarov can do lengthening, Elizarov can do angular correction, and Elizarov can do translation with the original Elizarov components. Right? But if you want to do angulation, you need hinges. If you need to do translation, you need the translation construct, which is obviated by the def fix and any 6-axis system. Personally, I don't think any one 6-axis system is necessarily better than the other. All of them are practically the similar aspects. It's just that, first of all, of course, def fix is available in India at a reasonable cost, where the others are not. And we've been sort of fortunate to have others come before us, so we've taken good parts of the hardware and the software from other systems and amalgamated them into the def fix. So we'll start with the hardware. Right? The hardware is essentially struts and connectors. What you see marked with the red arrows. So you need to have 6 struts, all, and that's why they are called hexapod systems. All of them will have 6 struts. And to keep this stable, you need all the 6 struts connected and stable. Then you have what's marked in blue, the connectors or the ball joints to connect those struts to the ring. And finally, what you have marked in yellow is certain kind of devices which will allow you to compensate for too much distance or too little distance between the rings. What you will see in this is the black alloy rings which have been introduced. But this can be equally well used with your regular Elizarov rings. And that, I think, is one of the biggest advantages of the def fix, that you have Elizarov rings, you can use it with regular Elizarov rings. With the other systems, you need to sort of buy into that entire system. And you'll see as we go along that you don't need particular places. Those of you who have been exposed to the TSF, Tailor Special Frame, or some of the others also, they have the concept of tabs and master tabs and tabs, where the struts have to be connected on the ring in particular positions. Whereas with this, you don't need to do that. Okay, next. So that's just a list of things. So we are going to show you the differences between the steel rings and the alloy rings, how we count the connector positions, and how we measure the strut lengths. We've put the sets on your table, so when we come to that part, we'll be able to play with it. Go on. So these are known as Y connectors, obviously because of the shape that they have. And this is what provides the connection to the ring. So the Y connectors are on the ring, and on those balls you see over there, that's where the struts will connect. There are two, I think you have Y connectors in it, you can pick it up and see it yourself also. So there is one portion where, which is flat, and there is another portion which has a ledge. The ledge portion is always fitting onto the ring, and that is because that provides a protection against rotation. There are just, you can probably make the arrow bigger, I think. And if that doesn't work, then use the laser. सबसे बड़ा करते हैं. I don't know whether it will work on PowerPoint. Anyway. Yeah. It's the same. Use the laser. नहीं उसका laser, PowerPoint का laser. Pointer option होगा ना. जहाँ पे पेन है, left lower corner. Yeah. Right. And it's kind of angled a little bit. Okay, go on. Now there are two. One is the steel one, that is steel colored, and the other is black alloy. And you don't mix up the steel ones and the alloy ones. If you are using alloy rings, then you need to use the black ones. If you are using regular Elizarov rings, then you need to use the steel ones. And the reason for that is the distance from the hole to that ledge. The alloy ring is a little bigger in dimension, right? It's a little broader and it's a little thicker. So it will not fit, the black one will not fit well onto a steel ring. And this is how it fits in. There is one threaded hole over there into which a regular Elizarov nut can be put. Okay. There is also, go back one second. Sometimes you may not get a completely black one, but it will have a large black dot on it. This also signifies that this is meant for the alloy rings. Okay, go on. Then we have something known as the C plates. C plates essentially are mechanisms to lift or take down the point of connection relative to the rings. You will see that in a moment. Again, that is steel and alloy. Go on. Then the heart of the system, that is the struts. We have three different lengths: small, medium, and large. I would say 80% of the time, and for relatively moderate deformities, the medium strut serves the purpose very well. Only occasionally you will need small or large struts, and even there are tricks that you can use to use the medium strut without trouble. Okay, so there are, if you look at the struts, there are two ball joints on either end, and there is the shaft portion. We'll come to that in a bit. Okay, go on. Now, how do you attach that Y connector? A regular Elizarov, you can keep playing it. The regular Elizarov nut is what works to connect it. The Y connector has got a threading, so you don't need a nut for that. The Y connector itself is a nut. So you just put in the bolt, and tighten that. As with all Elizarov, you should tighten these really tight, okay, so that it does not move. This, you should not put it this way, you should put it with the ledge facing, and you can put it above the ring or you can put it below the ring. Both of them are for practical purposes the same. Go on, I think we have shown that. So after finger tightening it, then you will tighten this with a spanner so that it then doesn't move. And because of the ledge, normally I always say you need to use 2 spanners. This is the one situation where just 1 spanner will do. So if you see this, stop there. One is put above, one is put below. But both of them, the ball joint is exactly at the level of the ring, and that's why that ball joint is slightly inclined, if you notice. Now there will be situations where the ball joint facing up is a little better in terms of getting you connection, and or the ball joint facing down is a little better. General rule is we tend to keep it facing down, but even if you put it facing up, that is on the lower surface of the ring, it's not a problem. Okay? Go on. Okay, next slide. Similarly, the C connector. C connector has got a sort of lip. The lip is like the ledge on the Y connector. So therefore the C connector will always be connected to the ring with the ledge against the ring and not the other way around. Again has a threaded hole into which a regular Elizarov will go in. And on top of that, you can put in the Y connector. So essentially what this has done is, this has raised the connection from the ring. If your rings are too close, you can increase the distance between the rings by using the Y connector. So when we do this workshop, you will realize that. So there is one C connector above, one C connector below, and one at the level. So that's how we use that. When rings are too close together, we may put the C plate above. When the rings are too far, we may use the C plate below, and therefore extend the usage of our medium struts. Go on. Just to underline the point that black on black and steel on steel. Don't mix up the two, because not that the dimensions are terribly different, but it will lead to a certain amount of instability because the dimensions are slightly off. So if you use black on steel, it will be a little relatively unstable. If you try to put a steel one on this, you will not be able to do that because the dimensions are different. So you will just not be able to put the steel. The vice versa, alloy on a steel ring, you may be able to do it, but it will be unstable. This does not fit. That's how the dimensions are. Next. Yeah. Okay, so now the struts. The struts are labeled small, medium, and large, and you can keep playing it if I require help. That's the ball joint, and hold there for a moment. You see a small wire there under his left thumb on the left side there. That is a lock. This snaps onto the ball joint and comes off on the ball joint. prevent inadvertent pulling off by the patient, we can put this lock on that, and then that will prevent the patient from pulling it out accidentally. Go on. So on the outer cylinder, we have written there #B. This will become, this you will realize when we are doing the software. This is one measurement that we do in terms of the length. So that is, in this medium, it is from 0 to 52. So straight away you can change the length of the strut between 0 and 52 in an acute fashion. And the point to note over here is this increases in steps of 2 millimeters. So you have 0, hold there for a moment, go back. Yeah. So if you see from 0 to 52 in 2 millimeter increments, and the number that is to be read is the one directly below the long mark, right? So that's 28, that's the long one. The next small one will be 30, then will be 32, etc., etc. And you can lock it into that position. If you see on your own models, you will see that the upper edge of this is slightly serrated, and that's what allows that upper collet to engage securely. Now the nut on that, when you use this, has to be tightened, right? But it should be tightened with gentle force, not the orthopedic kind of thing, because this is not something which needs to be strongly tightened. As long as those ratchets are engaged, this will not move. So you just need to have it firmly tight. So that fixes your part of the strut length, what is known as #B. Okay, go on. Then there is an inner cylinder which has got other markings in increments of 1 millimeter, right? So you will see one long one, and between the two long ones there is 1 millimeter marking. So that number, like 145, just go to 145, that refers to the long mark to the right of it, right? Sorry, left of it. So this, where his marker is what is 145, right? The long marker to the left of the number, so that's 145, this is 150, and the next one is 155. So here you can measure in millimeters, because this is what we are going to be distracting, right? So on the right side you can see now he has the clicker. Okay, there is a marker within that, right? A small steel ball. If you look at the strut yourself, you will see that you are able to see that small marker. So you can actually measure the length of the strut from there, the length of this second part. So what is the marker at? 120, right? Because it's at the long mark, and to the right of that is 120. So that is at 120. And as you turn this distraction or compression nut, you will notice that this marker will move. So that's 120 is for this strut. 125 is for that one. So essentially the number is written to the right. So this is 120. And as we distract and compress, that's, you just move it in the plus or minus direction, you will be able to see that marker moving. The ball joints, one side is mobile, the other side is kind of fixed, it does not rotate. That's just to allow for ease of movement. And this is a locking wheel. When that is tightened, then you can't move anything. You have to keep it loose to move this distraction nut. And that is four-sided, so that you can do your distraction 4 times a day if you want. 0.75 and back to 1. So if you move it in the plus direction, you are going to get longer, and if you move it in the minus direction, it's going to get shorter. So I mean, at the end of doing all of this, you will get a program where the program will say, okay, this strut is being distracted, this strut is being shortened, etc. So that this is how the patient does actually the distraction. Now on your sets, if you see it, when you turn, there is a little click on that. So patients can actually feel when they have done 0.25. So every 0.25 it clicks. So it's easier for the patient to distract. Still, even if they do make a mistake, it won't be more than a millimeter or 2. Now, as you distract this, you see this keeps moving, and this is even in clinical practice. This is reasonably easy to read. Okay, next. So that inner number is known as #A. This, as I said, just gently tighten it to engage the ratchet, and the inner number is #A, the outer number is #B. It's all of this is stated over there, so it's not very difficult to catch on. Next. Then we have these markers, color-coded markers. This will match the colors that we use in the software, just for the ease of the patient, which is strut number 1, strut number 2. So you have 6 like that, each of them with their own color, and there is a groove on the strut where it fits. Now, depending on what the program tells you, you can turn the strut this way or that way. Just go back a little. Little more. It was facing the other way. Yeah. So when you place it this way, it's essentially to tell the patient, remember, this strut has to turn in this direction. And you can place it the other way if you want to instruct the patient to turn it that way. That is essentially distraction or compression, which you will get at the end of the program. These are all just things to make it easier for the patient. Yeah, next. Now is the important part. So we've got all the basics. We got Y connectors. We got C plates to extend or reduce the distance. We got struts. How do we place the struts? Right? And that becomes the sort of important portion. For most things, there is a convention as to how you should do it. I mean, why do you say this is AP? We named it as AP. You know, when you take an X-ray like this, you call it an AP X-ray, antero-posterior. When you take it like this, you call it lateral. That lateral word could have been anything else. Similarly here, we are going to use a nomenclature which is fairly straightforward. When we teach Ilizarov, or at least when I teach Ilizarov, I try to say that the center bolts in all the rings should be aligned to each other, number one. Two, generally speaking, the center bolts should be aligned to the front to back axis, that is the AP axis, right? That will be in the sagittal plane, right? So the front bolt and the posterior bolt will be overlapping each other if you take a perfect APX. And none of us is ever perfect, but that's what we aim for. You don't want the ring to be completely rotated like that. A little bit this way, that way is fine, but we're aiming for it to be. So we take that point as the 0 point. Now, so which means basically that if I say this is the AP, now here we have put the ring slightly rotated, if you see. So here if I have to say, I would say this is the 0 point. If you've been successful in putting your, you look at it this way, right? That's the transverse axis, and this would be the perpendicular to that. So this would be the 0 point in this particular setup. You try as far as possible to get the center bolt put center, in the center. Now, taking that as 0, we will count to the right. But you notice here I have marked multiple holes with that yellow. And I would not fight with you, or the software is not going to have a problem if you mark any of these holes on the front as hole 0. Okay? It's not that, oh, if you miss this and you put it over there, then there's something terribly wrong going to happen with the software. No. It will still work because these are relative numbers. But as a general rule, try to be as accurate as you can. That's it. So somewhere on the front, on the upper ring, because the upper ring is always the fixed ring, and the lower ring is going to move relative to that stable base which you have. So we have now a new concept in terms of the upper or stable or the fixed ring and the lower or the mobile ring. So in the upper ring is we start with hole 0, and then you are looking at the patient and you are counting towards the right. That's the way. So this is a norm. We count always to the right. Forget about clockwise, anti-clockwise. Clockwise, anti-clockwise depends on who is looking at it and from which end you are looking at it. You just look at the patient and count to the right. So here, this one, and in contrast to the alloy rings, steel rings always have one hole missing because of that ledge. That steel ring has to be bent a little, and you see an area which actually should have had a hole, but for engineering reasons you can't put that hole, it will weaken the ring. So when we count that also as a hole. So this is, yellow arrow is hole 0, to the right of it is hole 1, to the right of it is hole 2. All rings will have a fixed number of holes. So now which is not the case in the alloy rings, okay? Because the alloy rings are made, they are thicker and they are made by sort of giving a half cut on the end. So there is no missing hole. On steel rings there is a missing hole, and you should remember that. So that's hole number 2, then 3, 4, 5, 6, 7 right at the edge. Okay? So counting, start from hole 0, counting to the right. Next. same thing. So now, let's count the struts. This is 0, this is 1, this is 2. Now count, tell me that one what it is. Which hole is that? 16, right? And you continue counting again to the right. So that was 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Right? And of course, if it was attached somewhere here. Now, so this is how you count. But here, this picture is to show you how do you space out the Y connectors. I told you that you don't need to have in particular position. So for example, if I had maybe a wire coming in here, then I can very easily put this Y connector somewhere on this side or somewhere on this side. The goal is you want to have all the Y connectors as equidistant from each other as possible, and that is something which visually you can make out. Once you put it in, you can count the holes and see that the number of holes between all of these is kind of similar. So between this there are 14 holes, and between this there are 16 holes, doesn't matter. A little bit of plus minus is okay. Why do you need this? Because in any hexapod, when you want to connect it, the more it looks like a symmetric V, the better it is. So if you have it very vertical on one side and very open on the other side, it is not as effective as if they were all in equivalent V's. So it makes for a better frame. So on the upper ring now, that is the fixed ring, we put our connectors. Okay. Then we have to go to the lower ring. Okay. How do you put it on the lower ring is somewhere in between, in the middle of those two connectors. You see that's the distal ring over there, and you can see in between these two. Again, there is no strict counting or strict formula. Visually you divide it into two and you can put your strut over there, the connector over there. One hole this side, one hole, two holes this side, not a big deal. When you do this more often, it comes like this. Putting on the Y connectors doesn't take us more than 5 minutes at most in terms of placement, and then you tighten it and all that. Yes, but it's not. I'm explaining this to you in much more detail so that you start off on a simpler way. And so effectively what will happen then is, if you look at the entire frame, you will see, if you see it end on, right? We've got a picture. No. Go back a little on that. I think on one of those pictures you can see.
आप शुरू में वो दिखा के बाद में पीपीटी ले सकते हैं, क्योंकि वो बात कर रहे हैं तो स्लाइड ही नहीं दिखेगा तो पता कैसे चलेगा किस चीज़ पे बात है. अगर वो पोडियम पे खड़े हैं तो दोनों साथ में ले सकते हैं.
Go back.
उनका तो कुछ ही नहीं.
Right. Now if you look at this, you will see that at regular intervals you have 6 connectors when you see that whole frame end on. Okay. Now when you are doing this on the patient, you are not going to be able to do it like this. So you will have, let's say, one Y connector here, another Y connector here. What's in between these two? This one. Drop this down. This is where I will put my connector for the mobile ring. If I have two here, this seems to be the center. Just drop it down here. If I am one hole here, doesn't matter. General idea is to be as symmetric as possible, and this is like regular Elizarov also. Elizarov, you can put in wires whichever way you want, wherever you want, but the more symmetric you are, the more pleasant it is. It's actually much more biomechanically stable also, and it's easier for the patient also. Right? Okay, go on. Now to connect the struts, you have to take out those locks, and there are two ways to fit this. You should always fit it with a thicker tube below. That is, the distraction portion should be on the upper part towards the fixed ring, not the other way around. And you just snap it. You can pick up take out that lock. Just be careful, don't it jumps out. Take it out carefully and put it back into the tray. And you can then just snap the Y connector into that and take it out. Snap it and take it out. There's a distinct feel that you get that yes, this connects well. Right? And you put it in such a way that the distracting portion, the thinner cylinder, the hash A, is towards the fixed ring. So now we've got on this, we already have 6 struts. So the struts will be lower portion on the mobile ring, and then the upper portion will always be to the right of that, angled to the right. So we put 6 connectors. Now we have to number the struts, which is strut number 1, which is strut number 2, strut number 3, etc. Again, this is a convention and a nomenclature. So just pay attention here how we do it. Once you have to you have to name only one strut to start with, then everything else follows, right? And as I said, our convention is to the right. So once you have named strut number 1, then the strut to the right of strut number 1 is strut number 2, 3, 4, 5, 6. So which is strut number 1? These are the points. First of all, the strut in the front. Alright? The strut in the front from mobile to fixed, that is below to upwards, and from left to right. It has to fulfill all of these criteria. These videos are there, don't worry. These videos are all available on the web. We'll give you a link to that. And exactly the same thing that we are talking about is there in detail on the web. So, can the red one be strut number 1? It is on the front. It is from mobile to fixed. It is from below to up, but it is from right to left. Therefore, only the blue one fulfills those criteria. And you will have situations where you will get maybe here it looks nice and to the front. You will have situations where the strut starts somewhere here and ends up near that pin. That doesn't matter, as long as it is meeting the criteria of mobile to fixed, below to up, left to right, and on the front, right? So here, strut, that the red one, the blue one is strut number 1. Then to the right of that is strut number 2. So the Y connector to 3, But notice that all of them are with the distraction nut above. 4, 5 and 6. Right? So our counting pattern is always to the right. We identify strut number 1 and then count from there. Next. Now, how do you count the holes? In the software, we have to tell the software where is each of the Y connectors connected. Actually, we have to tell it where the struts are connected. Right? Now, go back once. Show your hole 0. Yeah. Okay. Stop there. Now, if you notice, the center bolt of this is about 2 holes to the right, but where he's put the pen is what seems to me to be the properly aligned to the front of the knee. So I will take that as hole 0. Okay, and then from there I will count. That's 1. Hold it there. So that's 1, 2, 3, 4, 5, 6 and 7. Okay. So now if I have to tell the software where is strut number 1 connected on the fixed ring, where is it connected? Hole number 7. Also, strut number 2 is also connected to the same hole because it's a Y connector. Right? So this will come up when we are filling in the details in the software. And this we have already done. Go on, play. We said that we continue. So stop there. The yellow one is strut number 3. So strut number 3 connected on the proximal ring at that hole, and strut number 4 also connected to the same hole. Go on. The one, yeah, this should show the right one. No? So that's on the mobile ring. Stop. Go back a little, sorry. Yeah, hold it there. Hole number 0 I defined on the fixed ring. Relative to the fixed ring, I also have to derive hole number 0 on the mobile ring or on the distal ring. And that is again just by dropping a straight line down from there. So this one. Right? Whatever you took as hole number, everything relates to one point. Everything is relative to one point, and that one point is hole number 0. From hole number 0, you will find out where your struts are connected. From hole number 0, you will find out where do I start counting on the distal ring. So that here on the distal ring, we will start counting from there and then go forwards. Same thing, go to the right, taking that as 0. 1, 2, 3, 4, etc. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So hole number 2, strut number 2 on the mobile ring is connected to 12. And same thing with 3. 3 on the distal ring is connected to hole number 12. Okay, next slide. That's fine, we can go to the next slide. Remember, steel rings there will be a blank area where there is no hole. In the alloy, that does not hold true. So whenever you are counting, depending on which system you are using, that's the missing hole compared to the alloy rings. So if that's 0, then it's 1 and 2. Again, just pointing out the same things. The straight front to back line is hole 0, and then we've got some X-ray markers, the ones with plastic. There, it's in a plastic pouch there. They look the same, right? Can you tell me what's the difference? There are 6 to mark the struts when you're doing an X-ray. Just look at them and tell me what is the difference between them. All of them are made of plastic. They have a stainless steel wire. There are different combinations of thick and thin. If you see on the right here, number 1 has got 3 thin. Number 6 has got 3 thick. If you look at number 4, 2 thick, 1 thin. So this is something that can be identified very clearly on the X-ray, and that's how this is also present in the software to enable you to find out which strut you are looking at, because in real life it's not going to be like this. In real life it's going to be X-rays only. So there you will identify it by the X-ray markers. So when the patient goes for X-ray, we put on these X-ray markers, so we get that notification. Next. And the other thing you have to remember is to use a scaling object. You have to tell the software, this is the magnification in my X-ray. So what we do is we put the scaling object on the X-ray film itself. Right? And on the X-ray film, magnification is practically 0. Ideally, it should be more than 80 millimeters to minimize the errors of measurement. So we say use a 100 mm wire. So that wire is placed on the X-ray. So now you tell the software that look, this shadow which you see is 100 mm, and we are supposing that there is 0 magnification when it's on the film. So now the software knows that okay, what is the real 100 mm is this. We have also told it, we will also be filling in what is the strut length, etc. Using that magnification, we have told it that the strut length, so what will happen, suppose this is 100 and the strut is also 100 and the strut is somewhere there. What will be the apparent length of this strut? More or less. The further away you are from the X-ray plate or closer to the X-ray beam, the length will increase. So software will see on the X-ray, he's told me that the strut is 100 mm, but I am seeing it as 200, but it knows that what real 100 is, and therefore it will extrapolate what is that position of that strut. So that's why the magnification marker is important. Go on. When you are doing this, when you are doing the workshop, when you do the actual X-ray, this SFD is source to film distance. So that's the distance between the X-ray plate and your X-ray tube. We keep the plate directly under the patient and not in a bucky. Right? So when you take the pictures, this distance will be the source to film distance. That is from the bottom, that is the floor, to the camera. That you will measure. We will show you this again when we are talking about that. In X-ray rooms, usually this distance is 1 meter if you keep your tube at its maximum. But there will be occasions when you will turn the tube to do a lateral. There you may need to measure it, but commonly it is 1 meter. Yeah, go on. When you go back, let's come back to this when we are doing the workshop actually. Yeah. Sorry.
Now we can add.
Yeah. So now all of you all have this model. Okay. We have put on the rings already to save time. But what I want you to do is look at this. Each of you all will have slightly different. This is the transverse plane. And based on this, what is the front to back axis, and therefore which is hole 0. So put on your Y connector here, and then put in 2 more Y connectors kind of equidistant, and then put in the Y connectors for the distal also, and then fit your struts to those. So do this step by step. Fit all the Y connectors, ensure that they are tight, and then start putting in the struts, and try to use medium struts as far as possible. You can change the length of the strut as I told you, and then we are moving around and we'll keep an eye on that. Yeah, so now if you already have nut there, you can go a little this side, this side. Transverse plane. I would say this. But if you put it here, it's not going to create a problem. It's just that I like to be as possible. So I would say this is good. But you're not, I mean, a little this way, that way doesn't make any difference. This on the upper portion. Here is facing down. Times out of 10 you will find that yes, we have been more or less accurate. Okay, one goes this way, that's right.
Take it 730. All the Y connectors, if they're facing towards each other, that means your opening is
Yeah, no, so you still get less from here.
the first one.
So you can put it out to its maximum length, but use a C. Actually, if you use one second, if you use the C here, it will work for both of these. Yes, 12. तो ये एक और इधर आ गया, तो 12 इधर आएगा. 1, 2, 3, 4, 5, 6, 12. 13 या 14 में ये आएगा, so then it will become equidistant. So visually ही you can get an idea. Which is holes, that is for counting the connection. But where to put the strut is not from 0. See this one, suppose this is 0, and you put this connector here. yellow dots, right? And this is hole 0. Suppose I had some fixation over here and I could not put it here, and I put my first connector over here. What will be the number for that connector? Meaning in terms of hole, you will have to count all the way around. 1, 2, 3, 4, 5, blah, blah, blah. 38, 39, 40, 41. Get the point? Hole 0 and where the connector is connected are slightly different things. They are not connected. They are not directly. The first connector is not 0. Hole 0 and relative to hole 0 where my first connector is connected. That's all. Correct. So that's what. Okay. So to instead of this, what if you put a C plate here? You've got everything. You can use it. But also, if oftentimes what happens is, I think the set is X number of medium struts and a couple of more. So maybe you have one large and one you have only one large. Then you will have difficulty. So then you can put the C. So everybody will be using the same model, the same pictures and the same measurements that we are using on screen, so that you are able to follow it easier. And then the next step will be for you all to photograph your own models and do that correction. Does everybody have the, what is the name of the folder?
Goa Workshop 1.
Goa Workshop, Goa WS, a folder we have given, which is on your desktop. Anyone who doesn't have that? Airdrop it. Or we'll give it to you on this thing, no? Or you don't have a... Okay, just keep your airdrop on. Airdrop करना. Wi-Fi and log in to the software. You should use Chrome browser or Firefox browser. Go to deftfix.com, deftfix.com, and you should get a screen like this, which asks for your email and password. The email will be what Twitter people have given to you, the combination of email and password. So enter that. Divya, you can put yours in, just the email. Workshop. Work. Okay. 21@gmail.com. You haven't got a login? Hotel. On the right, you will see granted cases is 4. So this software is limited in terms of the number of cases that you can do, and it can be renewed again for newer cases. But so we click on add a case. There is the small square with a plus on it, the orange one. Click on that, and it says add case, and you will get this new case. Automatically that's populated. So you can change this by editing. Just edit. Click on the pencil, and you can change. If you lock it, it won't be possible. Unlock. Now you can change the case information. So when it comes to a patient, you can put in patient name, etc. So for our purposes, we can say tibia oblique plane or something, or Goa workshop 1, and save. So now we've got one case in our list, that is the oblique plane, workshop 1, or whatever you have named it. And then, not as yet. Everyone got that? Okay. Put in that username and password. So we've added the demographic information. Now we need to add the images, right? So click the square with the arrow, and you will get this screen which says upload AP X-ray, upload lateral. Click on upload AP X-ray. Click on upload AP X-ray and navigate to your desktop, the Goa WS1 folder, and in that you will see an AP model JPEG. Click on that and say open. So now that software is being taken up and going to the server. All of these calculations happen on the server, and you'll get this So right now we are just going to upload the AP and the lateral X-rays. Do the same for the lateral. Click on upload lateral X-ray. Navigate to Goa workshop 1. Click on lateral X-ray. And you should have a screen now which looks like this. Left side with some numbers that still need to be filled in, but AP and lateral X-ray you can see on the screen. Right? Now, on the left side, you will see AP, SFT, all the measurements here are in millimeters. Right? So you will see AP, as if at any time, I'm going too fast, just put up your hand and ask me to stop. Call one of us. Yeah. No, this is an issue with the computer. What this one are you using? What browser are you using? किसका कंप्यूटर है राजू?
कौन सा?
ये वाला?
हाँ मेरा है।
क्या हो रहा है इसमें?
ब्राइटनेस कम हो गया?
हाँ। क्या पावर?
नहीं मेरे ख्याल से तो पावर तो
इट्स काइंड ऑफ ऑन।
अच्छा।
और कोई है तो देना है?
हाँ एक दे दो।
पावर तो है?
हाँ पावर।
ये हमारा एक बार नहीं मैं वापस काटता हूँ। Yeah.
इनका लैपटॉप है सफारी के
कर लेना।
खुद का फोन करते हैं इनका भी 7-7 के लिए
ये क्यों नहीं चल रहा?
चल रहा है बाकी सब नहीं खोल देते
जब तक इनका
उनका वो ब्राउजर डाउनलोड
कर लो ना, जल्दी से हो जाएगा। We'll just download it. Till then you work on it with the others. Okay, go back. All right. So now, just attention to the screen, please. So we've got AP SFD, that is source to film distance. We've got AP scale. We normally, as I said, we keep it at 100 for AP as well as lateral. So the AP SFD is, you can enter it over there. 1110. 1110. All these measurements are in millimeters, right? And the scale is 100 millimeters, as you can see over there. The lateral SFD is
1145.
1145, and the scale is also 100. Okay. Now note that there are two colored things over there. One is a yellow bar with two side bars to it, and the second is this red cross. Okay. So let's look at the yellow bar first. If you click on the yellow bar, yeah.
नंबर फीड नहीं हो रहा है
क्या नहीं हो रहा है?
नंबर जो है ना फीड नहीं हो रहा
Just put it. The other one. कौन सा है ब्राउजर आपका? नहीं, use Chrome. Use Chrome or Firefox. Other browsers may give trouble. Just do the same thing in Chrome. अभी तक जो किया है ना, Chrome में कीजिए. Why the distance is 1110? Because this X-ray was taken at a distance of 1110 millimeters. Means the photograph we took was from this distance. It's not an arbitrary figure. It's a measured number. So if you are doing an X-ray, you will measure what is the, as I said, in an X-ray room this is usually 1 meter. That is 1000. So let's look at the yellow bar. You can manipulate that yellow bar. If you place it on the center, if you place your cursor on the center and drag it, you can move it up, down, left, right, anyway. Alright? Go up into the, yeah. Then there are two blue dots in the corner. If you click on the one of the blue dots, it will angulate, it will shorten, it will lengthen. So what we normally do is take the lower blue dot and place it on the lower portion of the X-ray marker. We are telling the software that this is the lower portion of the X-ray marker. Then take the upper blue dot and put that on the edge. Okay. Some of you may have the X-ray looking very small. Divya, yeah. You can zoom in and zoom out. If you have a mouse, you can use the scroll wheel, or you can double click and you can. So I usually like to zoom in to the maximum when I am placing all of these things, because that makes it the most accurate. So you may feel that it's a little bit of a headache zooming in, zooming out, but that's the simplest way to do it, and once you're doing it regularly, you get used to that. So now we have changed this to tell the software that this is 100 millimeters. This is the length of 100 millimeters on the AP. Do the same thing on the lateral. You can drag it down and then do the fine tuning. So that's 100 millimeters. So zooming in, you can use zooming in, zooming out. You can use the scroll wheel. If you have a trackpad, you can pinch, or you can double click. Double click gives you only one image on the screen at a time. If you double click again, you will get both. So if you want to focus on one, keep it on the left side and double click. So now we are seeing only the AP. Double click again. Now we are seeing both. Put it on the right. Double click. Now we are seeing only the lateral. Double click. So you can play with that image as you like. Now another important part. This part is very, very important, and the software will remind you also. The red cross is what is known as beam center, right? When you go to the X-ray department, the X-ray tube has got a light in it, and it has a collimator, right? And in that usually there will be a cross. So this red cross is to be put where that cross is present, because that is the center of the beam. Okay? How will you know where this beam center is on the X-ray? When the radiographer takes an X-ray, he puts some sort of a marker. In our X-ray department, we put the digit 6 wherever is where the beam center was. So when we show you X-rays, you will see that there is a radio opaque 6 where that crossing, where the collimator crossing was. So that is the center of the beam, because there is, from the center of the beam, there is always a certain element of parallax. So you have to tell the software where is this center. So again, you click on the blue and you move it. Usually when we are doing these X-rays, we put it on the center of the osteotomy. Okay, on both the AP, and you notice that as he does that, there is a tool tip which comes. So if you are not, if you sort of forget, when he puts it there, you see X-ray beam center. So place that in the lateral. Okay, and then we can go to the next portion. There is a red arrow, orange arrow on top, and you can go with that. Yes, on the marker, not on the, and So it starts with the X-ray person centers it more or less on the osteotomy, gets the beam centered there, puts the marker there, and so when you get the marker, when you get the X-ray, the marker will be more or less in the center of the osteotomy. We cannot see exactly where it is, but roughly wherever it is, that gives you the best visualization. Now it will show, just knock off the SFD there on the AP SFD or lateral, whichever one. Okay, so now see that arrow is not enabled. You can't go to the next step until you have put that. If any data is missing and you have this also, scale should be something whatever. Right? So put it 100, now it will get enabled.
The lateral should be the center of the middle.
Center of the, it should be wherever the center of the beam is. Here now, because we have taken the picture, we have kept it exactly over the osteotomy and done it. So that's the beam center. Wherever the beam center was. Right now you can keep it in the center of the medulla. Okay, now it's enabled and I can go forward. But it will still remind you, but be sure that you have placed the annotations, because the annotations are already there. They have to be in the right place for you to do it correctly. Right? Numbers you have to fill in, but the annotations were already there. And if you don't put the annotations where they are supposed to be, then the software, so it's giving you a warning. Okay? So sometimes it disconnects, but every step that you do is usually saved on the server. So you will come back to the same step. So now we have told the software where is the center of the beam, where is what is the magnification, but the software doesn't know whether you are using a 140 ring, 160 ring, 180 ring. Right? What is the distance of the rings between each other, which are the struts. So that is the data that you have to give it. So the first thing, fixed ring. In this case it is 160, I think. It's a drop down, and these are all the types of rings that will be there. So here we are using a full ring, and the diameter is, I think, 160.
160.
Okay. One. Give me one.
140.
160.
Where? No. We are doing
This model.
We are
This
doing
model.
our model. Everyone is using the same model, not yours. You will do next. Our model is 160. That's the one that you are working with. The mobile ring is also a full ring. You click that, select, and put 160. Okay. Now we have to tell it what are the strut lengths and where those struts are connected. So we'll tell you this. Divya is just noting it down for his. So now look at this portion. Strut number number 1, what is its position on the fixed ring, what is its position on the mobile ring, and then there is something which says C extension. Just click on C extension. NA is not applicable. You click it once, it shows up. That means the C extension has been put on the upper side. Click it once again, it will show down. That means the C extension has gone on the lower portion. And click it again, it goes back to not applicable. So unless you have put a C extension, you don't need to mark this, right? It will remain not applicable. So our strut number 1 is connected to the fixed ring on hole number 5. Okay. Connected to the mobile ring on hole number 43. Okay, you can enter now as he enters. Strut number 2, that is the one on the right. 5 again.
And 12.
12. Strut number 3 on the fixed ring.
21.
Just wait. Okay, 21. And where is it connected? Strut number 3 is connected where on the lower ring? We said no. 1 and 2, same. 2 and 3. So where is 3 connected? Which hole? Where is 2 connected? 12. So where will 3 be connected? 12, right? Strut number 4 on fixed ring is 21 again.
Same as 3. 21.
Because 3 and 4 on, you see on the back there are connected to the same one there. And on the lower 28. Strut number 5 is 37.
But there is a C plate. So we will mark that with down.
You see there is a C plate connected there, which is on the lower surface. That one. So you click so that it is showing down, and 5 will be connected on the same 28. Strut number 6, 37. Again, facing down. And last one will be 43. That is the lower one. Yeah, 43. S1 and S6 on the lower portion are connected to the same hole. So this is now strut connections. Where are the struts connected on my 160 mm full ring? All of these things are important. When it is connected on particular hole, when you tell it this is this many millimeters diameter, then the software knows that yes, this ring has got so many holes, and therefore it will take that into account. Then the next one, go on, is the strut length. In the strut, what are the 3 things we looked at? Is it a small, medium or long? What is hash B, that is the outer thicker cylinder, and what is hash A, that is the inner thinner threaded cylinder. So the first strut, again here, medium, large, you will cycle through. Every time you click it, medium, large and small. So this is a medium strut. Hash A is 145. Hash B is
52.
Hello. थोड़ा ऊंचा बोलिए. Strut 2 is also medium.
No, strut 2 is large.
Sorry, large. Hash A and hash B is 155 and 2. 110 and hash B is 30. Strut 4 is 132 and 12. Strut number 5 is 139 and 44, and strut 6 152 and 26. Okay, so we've got what is the size of the ring, where are the connectors, where are the struts connected, and what is the length of the strut broken down into A and B. So effectively total length of strut number 1 is 145 plus 52. Total length of strut number 2 is 155 plus 2. Right? So once you've given it this, then you will have the arrow turning green over there. Everyone got this? Enter. Go forward. Yeah. क्या हुआ?
His entry.
Oh, okay. So we've given it the numbers, and now we have to tell it how the struts are lying in 3D space. We are not actually telling it how it lies in 3D space. We are giving it two-dimensional sort of images. But from this, it is able to calculate as to what's happening in 3D space. Now notice S1, S2, S3, S4, S5, S6 are colored. These are the same colors that you will put onto that. And also notice that this is shown thin, 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 thick, thin, thick, thin, thin, thick, 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 thin, thick, and thick, thick, thick. So these are unique combinations, and you can actually see them on the X-ray. On X-ray, very often you will not see all 6 struts. You may not see all 6 struts, but or you may not see all 6 markers. Struts generally you will see, but if you can identify one, then you can identify sequentially from that most of the others. And so you have to mark this strut in AP and lateral. Now watch. Don't do this as yet. I'll give you the chance to do this. Watch. I want to show you all the manipulations that you can do to the strut length, to the strut. So when he clicks AP, on the AP, a blue line comes. Okay. It has got 2 ends. Zoom in maximum. So there is like a Moser circle over there. And if you keep the thing on that, this shows this is the fixed end of strut 1. So it comes placed like that only, fixed end. That's why we told you how you have to put the strut. There is one fixed end and a sort of mobile end. Also it's marked by that rectangle above. So just looking at this, you should be able to say that this should be on the upper end. Okay. And scroll down or zoom out. Yeah, now if you click on the center dot, it says move strut 1. So if you click on it, you can drag it left, right, up, down, wherever you want, without changing the length of the strut. And if you go down, that rectangle is missing. And when you click, when you place your cursor on it, it will show mobile end of strut 1. Now if you click on this and push it up, you can shorten or lengthen the strut, the line. Alright? And show the upper one only right now. Actually both of them. Take the lower one on this white surface. Yeah, and the upper one also take, it will be better visible. Right. You see Moses circles, right? You can see that? So now we can place this on strut number 1. Lower one goes on this, or I say roughly sort of does. A collection of small mistakes will extrapolate into a larger mistake. So that's why I say again and again, one is you should be accurate in terms of how you place it. Second is zoom in, zoom out. Now look at the way he has put this. This may look okay, but zoom in now. Okay. So visually, it's so much easier. Now just drag that. You can get it perfectly aligned on that ball once you're zoomed in enough. Right? Sometimes what happens is you don't see a part of that on the X-ray especially. You will not see all of this. You will only see this arc. But when you are zoomed in, you can match that arc to this portion of the arc so that it is perfectly, and you are kind of assured that yes, I am right on the dot on that. Same thing for the upper one.
Right click and drag.
Yeah, that's it. Now you can place it to where you can see it. All right. Zoom out again. So I've got strut number 1. And you need not always start with strut number 1. You can always, whatever is easily visible, you can start with that and then derive from there. So let's do strut number 2, let's do strut number 3. Alright. Now, which is strut number 3? It's written over there. Alright. But can you see the ball joint of strut number 3? You can't. Right? But this has a ball joint. Just place it in both places. So whenever you are using computers, you heard the concept of ego, garbage in, garbage out. Now if you, the moment you place that ball joint, you are telling the software that the strut begins here and ends over here. If you want to say that I can't see the ball joint, then you can right click on that portion and it changes to an arrow. So now there is no ball joint, right? Right click on the upper one, it changes to an arrow. Now you have told the software, I don't know exactly where the beginning and end is, but this is how the software lies, the strut lies. So try to get that line perfectly aligned with the strut. We are not looking at the ends. We are looking to see that it is well balanced in that strut. Right? So fixed end of the strut, mobile end of the strut, right click the strut to take away the ball joints. Now we will mark all the others, S2. Sorry? Yes? No, that is this one is the fixed end, which means the end which is connected to the fixed string. That's all. And the lower one is to the mobile end. So that sometimes what will happen is when you have severe deformities, the strut will be like this. So the software needs to know what is the orientation of the strut. That's why you should keep it that way. Yeah? Any sequence? You can put it as I said, whatever you can see well, you mark those first. And then what you can't see as well, you can spend a little time doing that. Now every strut and every ball joint doesn't need to be marked. It's not necessary that every has to be marked. But the more data you have, the more accurate it will be. So if you see, if you can see it, might as well mark it, right? Just someone go and check why he's angry. People are not doing it properly or what? कौन है बारी? आवाज बारी का ही है? हाँ बारी सर है। थोड़ा चाय पिला दो। थोड़ा चाय पिला दो। ये अपना भी वॉल्यूम बढ़ा। नहीं नहीं। Okay, so we are going to do the same thing. Divya just now show me both. Okay, finish 6 and then we'll go ahead. Finish 6 and then we'll go ahead.
Now, dear friends, very important point. Crystal rain is very chemical.
So, as many struts and connectors as you can see, the better will be your accuracy in terms of correction. Don't start as yet. One more thing I want to show you, then you start. Here I can't see the ball joint, so I'm not going to give it wrong information. Wherever I can see it, I will mark it. Alright. Now, so same thing has to be done on the lateral. Okay? So what is the definition of strut number 1, which is on the front, going from below and left to right. So this one. Right? No? This one. Because now you're looking at the side view. Right? So here, so this will be strut number 1. And of course here, now like for example, you can't see the marker here. What is this marker? When you get confused. What is it in terms of dimensions? Thin. So that is strut number 2. Right? So you have sort of ready reference all the time. So go back. So now we'll mark on the lateral. This will be strut number 1, strut number 2, strut number 3, 4, 5, 6. So go ahead. Mark 1, 2, 3, 4, 5, 6 on the AP as well as the lateral. And where you can't see it, right click to make it an arrow so that we don't give it wrong information. Yes. If you cannot see what, then don't put it on. If you can't see the strut, which strut is it that you are not able to see? That's fine. If you are not sure of it, you can leave. Usually, yeah, correct. But usually what happens is on X-ray, here you can't see it because this is opaque. But on X-rays, you will get a shadow of that. And you will usually get an idea of, okay, where the strut lies. But the basic principle is ego. If you are not sure, so there I would do all the tricks that I can, zoom in as much as possible, try to see it in detail, but still if I am not able to see, don't mark it. So even Divya has not bothered to mark S4 because he can't see it properly. How do we right click on the end, which you want to convert into an arrow? the strut has got an arrow, however long it is, it doesn't make a difference. So you can make it as long as the strut, because we are not giving it a fixed length information. Still you are not giving, because you don't know what's the other end. So you are not giving it. Yeah, you can have that. Huh? One end arrow and one end correct. You can do that, yes. But if you zoom in enough over here, yeah, probably not. So, but what happens, as I said, on X-ray is, because X-ray will still go through this, and you may get just an arc C. But in this case, yes, arrow is fine.
Right click.
Right click on the ball to convert it into an arrow. दिख रहा है देखो बॉल? हाँ. Okay. So here see, he is just able to see an arc of it, but still he is able to match the arc to the circle. Just give him the numbers now. Yeah, both are full rings, 160. Go back. अच्छा, you written it down. उधर ही बता ना. Back जाके. It will be easier. हाँ, okay. Connections also are there. Yeah.
You can adjust it to what you think is, no, not from one end to another.
So we've got all of this two-dimensional information. What is the lens? Where is it connected? What is the size of the struts? Blah blah blah. And we are going to give this to the software, and the software is going to take that. It's going to crunch up that thing into three-dimensional data, convert it back into two-dimensional data by drawing some lines, okay, and it will paste it back onto your X-rays, telling you that okay, this is what I think the deformity is. Am I right or am I wrong? Okay. Now just pay attention to the screen, please. So when you say calculate, all of this data goes to the server, and depending on how many people are using at that particular time, it takes a little while, because this is a sort of intensive calculation. So it's taking up all of that data and crunching it, and it will put it back onto these same X-rays. Consider amping up the speed. Yeah. So now it did all the 3D calculations, and based on that, it has taken a, let's say, an AP and a lateral picture of the images, of the 3D images, and it's presenting it back to you. That this is what I think is the calculated struts. So the length is not important, but the red lines should overlie the struts. So if you zoom in, yeah, or take one at a time, AP and lateral. So you can see that these lines are overlying the struts. They may not be overlying as perfectly as you drew them, but as long as they are more or less on that and not grossly off the strut, this is acceptable. There will be times when it is one of the struts is slightly off. It doesn't matter. Here, this is like a checkpoint, because there are many mistakes that you could have made earlier. Instead of 1110 as the source film distance, you may have put 111 and missed that 0. That changes the number completely. Strut, where is struts connected, you may have mixed up that. If you make a mistake in any of those entries, then these lines will not match. Okay. Now show the lateral. So we did put in S4, but still the software has shown where S4 is, because it knows where S4 is connected, it knows what S4 length is. So based on that, where should S4 be, it has already told you, and that is reasonably good. Look at, let's say this one, 2, even 3 now. This is, that's 1, 2 and 3. No, 2, sorry, this one. See, it's on the top, it's slightly to the left. Below, it is slightly to the right, but it is within the projection of the strut. That is acceptable. Worst case scenario, one is even more angulated. What happens is, it makes your correction a little less accurate. But the advantage of having a 6-axis is that you, how many times we have put on hinges, right? And we've been a little wrong in terms of the way that we put on the hinge. The hinge was a little higher, the osteotomy was a little lower, or the angulation of the rings was not good enough. And now your rings have become parallel, and you find that, oh, the bone angulation has not corrected perfectly. Then you have to go back and change your hinges, or your angulation has corrected and there is some translation. And what do we then do then? Normally we say, chalta hai. Itna to, this is good enough. Right? And even with this, many a time it will happen that you will find that, okay, this is reasonably good. But if you want to correct it even better, or if that difference is significant, then you just have to do one more program to change whatever it is. You corrected the angulation and there is still 10 mm of translation. You can correct it with this without changing the hardware. That's the important portion. Right? So now I want you all to click on calculate frame and come to this orange line step. It will take a little while since multiple people are doing it together, but it will happen. And then confirm that your orange lines are okay. If there is any question, ask me, Divya. Then you have to go, if the orange line is not okay, then you have to go back. Okay, wait 1 second. Don't start, I mean, if you have clicked it already, it will be working. We'll show you on this. Go back one more.
can't be 12.
It can't be 12, so that's why I'm saying just put 35 or something, or 30. I didn't measure it properly, so put it as 30. Everything else is the same. I gave it wrong data. So naturally, that cannot show me the right thing. So, not even 9 times out of 10, I would say 99 times out of 100. If your red lines are not matching, there is a problem with your data. Either the data that you entered or the way that you measured the strut or marked the strut. So while ours comes up, you can also set yours going and see whether you get the red lines or not.
काम करना एक्स्ट्रा है
Okay, so go back now. Go back. Show me the numbers. 543, 512, 21, 12, 21, 28, 37, 28.
So the software is already marked an error. And there may be some error in the frame parameters. So when you click, it will show that everything is off. So that's like an error check.
Go back one, go back one.
Go back and check the lines that you have marked and the data you have entered.
Now check the strut marking.
Change it back to the correct one.
So I would say
Now everything matches perfectly.
good, right?
So this fulfills all the criteria for better box. I can go for this one, but then this is on the side. I will not get that number. Yeah, numbering.
sometimes if the software is giving, and then again back onto that, drag that fellow onto the end. Same on the lateral. Now you can be just a rough drawing, or you can be Picasso by going click, very, very fine. Make a this thing between the two, where you get a reasonable idea of the outline. Okay. Same thing on the lateral. Yeah. You don't need to know, because what is it that you want to see? Divya, come down.
Just the fixation point.
No. Zoom in on the left. Zoom in. Yes, and drag down a little more. Zoom in a little more, and drag down. Go. Get that in the, or start in the center. Yeah. If these two are aligned to each other, you will get an idea in terms of what is the alignment. In metaphyseal areas, it will change. But for diaphysis, if shaft is aligned to shaft, that's good enough. So now zoom out. But you made the right point that you take the same length. You see here on the left, he is marked up to that shan screw. So on the right also you should mark the same length of bore. Alright? Go. So now we've drawn the mobile segment, which is the yellow one. Alright? And so suppose you made a mistake. Watch, don't start doing. I'll give you time to do it. I want to show you all of these intricacies in the software. Suppose he drew an extra line over there. Okay, now how do you take it out? On top, delete. Every time you click delete, one of the anchor points will be deleted. So delete. Same thing you can do on the AP also. Right? And when you click, it will draw the line, and we drag this to get it. So that's number one, how to mark the axis. Number two, how to mark the mobile fragment. Number two is you have to mark the axis. You have to tell the software that okay, this is the two parts that I need to get aligned to each other. So draw the cone axis, click that, and then in the AP and lateral, you will get fixed fragment and mobile fragment. In that, you get two parts, joint and shaft. Commonly for diaphysial, we use shaft because it's the diaphysial axis that you are going to use. But when you are at the metaphyseal region, then in the metaphysis there is no shaft axis available. So there we will draw the joint. But right now I am going to show you only shaft. Later, the next model, we will show you the joint, how to use the joint. So we click on shaft and you get this bunch of lines. Now there are three parts to this. If you click on the upper, if you click on the upper one and red one, you can move it in the same direction that you want. Okay. If you click on the lower square one, you can change the angle. And the lowermost one will only expand or contract the length of the line. Okay. Then there are two squares on either side that will help you to center the red dot. So if you put each of these on the cortex, that will be a center line. So now you can drag the whole thing onto the board, onto the upper, because this is the fixed fragment. Get those two things on the cortex. So now I've got the diaphysial axis of the proximal fragment, and that red the bottom has to be at the osteotomy. So everything has a tooltip. If you get confused. And this one is at the osteotomy. Okay. Same thing for the lateral. So yeah, mobile, AP mobile. Yeah. That's fine. Now, what is the importance of this red dot? Just pull that one up. This mobile fragment over there. Okay. Now, what am I telling the software when I keep it like this? That is supposed to indicate the end of the bone or the osteotomy. So essentially, I am telling the software that these two bone ends are overriding. Right? So the software will try to get these two dots coincide. So that's why you have to ensure that you keep it and pull it down. Yeah. So if it is this, what am I saying? They are distracted. So software will build in the amount of compression that is required. If it's overriding, it will build in the amount of distraction that's required. Yes. No, that's the previous line that we have drawn, that is to draw the mobile segment, is only a visual visual, what do you call? Indicator. It's not really giving any information to the, because points and axes are accurate. Tracings may not be accurate. So the axis and that point is the data which is going to the software. Okay? So we got it up to the correct thing, and same thing on the lateral. Now, though we are doing this in 2 dimensions, the software is reading it in 3 dimensions. Okay? So we've got this. Now, see where this is. Stop. See where this red dot is. It's down. And see what's happened on the left side. It's gone down. When we came to this, it was at the center. Now when he moves it up, that will also move up. Right? So this is working in 3 dimensions.
So these two dots overlap.
Yes. Well, it depends. It depends how your if there is translation going to occur, meaning cora is up and osteotomy is down, then they will not overlap. They will be translated to each other. In this case, it's a osteotomy rule 1. Yeah. Okay. So now, when draw the shaft again. So you don't need to calculate what is the magnitude of the deformity, because angle between the axis you can see is already shown. Okay, minus and plus only refers to the direction it is, but magnitude is 23 and 35. So you don't have to sit and calculate the oblique plane. Okay, go ahead, draw these 2 axes, then I will show you the next point.
It will not go to the next step.
Till you draw that, the next step will not be enabled. You saw when he did it, that became disabled. Now click on structure at risk. The upper ones become this. So it is a stepwise thing, because Today you may not require it, but for another case you may. So that's why it's built in that. So you do up to this, and then I will show you the, because structure at risk again needs a little explanation. Okay. No, the green arrow here. Yeah. Which one? You are doing it again?
Yeah. The lines didn't match.
And that's why we have to do a go. Now, in this case, for the cases, we will go to the intended access at 55%. Now, what we do is, we have the original mechanical access rule, we draw the shown in yellow. Now, again, you will again make sure that you are accurate.
Tell me when you're done. Huh?
So now what we do is, what we want is, you go down all the way to the angle. So first go to the original angle, the center of the angle, then we are going to the future angle, where the intended axis comes around the angle. Now, the first angle of measurement that we have here is the angle of measurement of alpha. That is how much we get in terms of the response. That we measure by to calculate that we find the angle between the line joining the angle center to the unit point and the line from the unit point to the future angle. Now, we talk about the unit point. So where should the unit point be? So just about the
Generally speaking, it's a good idea to use a mouse with this. Much easier to manipulate it with a mouse. Trackpads, though they are convenient, are little difficult to use. Alright, so now we come to the next structure at risk. Okay, what is this structure at risk? When you click structure at risk, you will get a crosshair on both the AP and lateral top. That table, that is shoulder. Yeah. So next step, structure at risk. Okay. What is the structure at risk? When you are doing a lengthening, which is the structure at risk?
Should be stretched out.
The thing which is being stretched, and in this case it's the bone that we are interested in. So therefore, essentially when you say structure at risk, it is the part on this which you want to go at 1 millimeter per day, where you want that distraction of 1 millimeter, because this is angulated like this. When we do hinges, we turn the motor at maybe 3 or 4 millimeters per day to get 1 millimeter per day over here. So essentially that's what we are telling the software. Which is that point on this bone that you want to drive at 1 millimeter per day. And this also is 3-dimensional seen in 2 dimensions. So normally this is on the concave border of the bone. Okay. So when we move it, you can see that one also moves. So you've got to get both of them onto the concave border, and this is the area that is going to go at 1 millimeter per day. If you put this on the convex border will go at 1 millimeter, but this will go at more than 1 millimeter, and you don't want that. Okay? This is the area which is going to get stretched. There is an option for structure at risk 2 also, which is not really useful or doesn't help us in any way. So now we finished all these bone annotations. Click. So it allows us to go forward. So now it is showing me that on the AP it is correcting an angle of 23 degrees On the lateral, it is correcting an angle of 35 degrees. There is 2 millimeters of translation in the AP and lateral. There is no lengthening and there is no rotation. Rotation is something that you can't measure on X-ray. It's a number that you have to put in. But zoom in here on the right. What kind of a correction is this? Neutral. What kind of a wedge? Neutral wedge, opening wedge, closing wedge. This is a neutral wedge. Because on one side you see the opening, on the other side you see the overlapping. Can this happen? Very difficult, because that bone has to crush each other. So if you want a pure opening wedge, this is why the outline is important, Manish. So now you can translate it. You can add lengthening. Every time you click on that, it goes down. And when it goes down on both AP and lateral. Okay, go. 6. Now that seems that it is distracted, but that's only the projection. And if I have to make a mistake, I will make a mistake in 2-3 millimeters more of distraction, because I can always compress it down again. So now, do you think that translation is alright on the lateral? Maybe 2 millimeters to the right is what I would like it. Okay. So I'm happy with that. On the AP it looks okay. So essentially at this step you can further fine tune whatever correction you want to do in terms of placing. And once you have this, then we can go for the schedule. So when you click schedule, you get a starting date. So today is what? What is today's date? 29. So normally when do you start your distraction? 8. I started on the 8th day. Okay, so today is 29 and therefore 6th April is when we want to start. Okay. And we want how much distraction? Normally we do 1 millimeter per day. In how many steps? You can do it in 1, 2, 3, 4, whatever you like. We usually prefer to do 4. The guys on TSF will do it one shot at a time. They don't do it 4 times a day. And apparently there are no ill effects. So you could, but I generally prefer 4 times a day. It's gentler on the patient. So now it tells you that it's going to take a total of 34 days. But you are the big orthopedic surgeon, big Elizabeth surgeon, and you know that for 35-degree deformity, I can do it in 15 days and there will be no problem. So you can change it then in the number of days. And you say, no, this needs 15 days. Okay. For that, you will have to get 2.275 millimeters per day of distraction, which the software will not allow. So after 2 days, 2 millimeters per day it will allow. So if you reduce that, then it will become 17 days. It will give you what we consider the standard, the recommended ideal, 1 millimeter per day in 4 turns, and accordingly it will calculate the number of days. But if 34 days is not falling on your outpatient day, then you can either do it for 34 days and call the patient on the next outpatient day, or do it in 32 days and call the patient on the outpatient day. That much change you can do. So now it shows you, so following all of that, this shows you 2 or 3 things which I'll show you now, and a couple of things which I'll show you later. What it shows now is, at these particular timings, 6 a.m., 12, 8 and 10 p.m. You have to turn, 6 p.m. and 10 p.m. You have to turn this, it says -1 plus 2. What is that -1 and plus 2? It is a click. Right? So that 1/4 turn on the distractor. So on strut number 1, you will turn it, patient will turn it in compression mode with 1 click. On strut number 2, distraction mode +2. Strut 3 is, so now this is 0.75 mm per day. This is what you may think, but that's on the strut. It's not on the bore. This is the distraction required on the strut to get 1 millimeter of distraction on the bore. So it also shows you what is the length at the end of that day. 144, 156 for the beginning of the next day. So that also, you know, if you are very worried, you can get the patient to check. Or when the patient comes midway, you've given the patient a 30-day program, but you are going to see the patient in 15 days. So at the end of 15 days on such and such day, what should the lengths be? You will have it on the schedule and you can go to the patient strut and check, is he doing it correctly or not, right? And at the end of it, go down. So now these red markers are showing you that this strut is going to reach its maximum limit. This is like a warning. And this one, strut number 4, will reach its maximum on the 18th of April. So you will need to either adjust that strut before the patient goes or call the patient on 17th of April and replace the strut or adjust. That will show you in the next part of it. But right now what I want you to notice is that you get a schedule, go out right down to the end. And these are the lengths that you will have at the end of the schedule. So if you get these numbers on your struts, the deformity will have been correct. Right? So now you can do all of these steps yourself down to getting a schedule. There is a possibility of one mistake, not mistake, difference, 34 days. Right? That will depend also on how you place your structure at risk. The more the structure at risk is away from the bore, the more is the number of days of distraction that it will take. So do all of this and then come to this step and see how you are, what numbers you are getting. Yes. A couple of millimeters, yes, you can correct. You can correct.
If it is significantly
like what? How much? 7-8 millimeters also on one strut is okay. If everywhere there is a problem, then you need to sort of re-educate the patient in terms of how to do it. No, you can just move it daily till it meets up to these numbers and then start again from there. Abhi, samjho 3 struts, go up a little. Go to maybe, that's fine, that's fine, okay. So highlight the 16th April one. Yeah, so strut 1 is okay, strut 2 is a problem. Nahi, niche, uske niche ho. Yeah. Huh?
This line doesn't.
No, I know, but just keep, so it becomes bold, that's fine. Strut 1 is okay, strut 2 is not okay, strut 3 is okay. So let's say alternate struts are not alright by 7 millimeters. So you stop it at that distraction and the rest of those, the struts which are not correct, say over a day or so, instead of 4 times a day, let him do 6 times a day, till he comes to this number. Once he's come to this number, he starts his distraction again. Only thing is that the date will be 1 or 2 days before. Now, can we do all of it in one go? Probably, I think you can do it. We've done 2-3 struts, 4-5 millimeters at one go in terms of correction. We do that because, as I said, that the strut is right over there, and 2-3 millimeters of distraction here is not going to affect it much. over here. But for me, the bigger problem is that if there are multiple struts where the patient has got a wrong this thing, the patient has understood what it is. So usually we only get this strut mismatch in struts which are difficult to reach or see. But otherwise, because of the feel, even there, because of the feel, it's not usually a problem. 1 millimeter होता है, that is adjusted right away.
So why do you say strut 2 is not correct?
Strut 2 is?
Not correct.
What do you mean not correct?
Why do you say strut 2 is
No, he was saying suppose patient comes back and some of the struts he has not been turning properly and the numbers are not according to the schedule, then can we change it? So I said okay, let's consider this scenario that way.
You can build it up in the schedule, add those numbers in the remaining schedule. If you want to do it that way.
Structure and risk what? Why did you miss? You were... oh, then it's okay. Sure, structure and risk. He has a genuine reason. If those guys had asked me, I would not have. Structure at risk essentially is the structure which you want to distract at 1 millimeter per day. Because if you go more than 1 millimeter per day, you are likely to have trouble. So in case of our situation, its hole will not form if I do at 2 millimeters per day. So the structure which is moving the fastest is the concave border of the bone. So therefore, we use these crosshairs and bring it to the concave border of the bone on both the AP and the lateral. But if you are not careful, you may leave one a little further away. Isko thoda dur rakh de. So we had 35 days there, right? Earlier. Now you see when we calculate what happens. Schedule? Alright. So it's gone to 44 days. Right? So generally, whatever is the angle, maximum angle of deformity is what the number of days it takes. So 35 degrees tha, 37, 38 I will accept. The moment I see 40, oh I made a mistake. So I will go back and check, have I put my structure at risk? So do your own thing and confirm that you are getting the same. Then you can, meaning like if you are doing a varus correction, one structure at risk is the bone and the other structure at risk is the peroneal nerve. But that's theoretical. I have never used structure at risk too. I just go with one. Still touching. So that's what I said. If I want to make a mistake, I will still distract 2 millimeters, 3 millimeters more till it's clear. 5 millimeters also, that's fine. This is only a projection. So I will do even 5 so that I am sure that it's not going to crash. And then I will compress it. Compression doesn't take any if anything, if you distract and then compress again, you are putting a larger volume of regenerate into a smaller area, it will heal better and quicker. I think we'll break for lunch now, once everybody is done. So now I want you to do this and then you will realize our maximum limit is only in 2 of them. You may find that you've got maximum limit in 3. Plan how to deal with these alerts. What should be done? Close. Okay. Or you may have put more distance. you put a not possible. Save that as the AP and lateral X-ray, import it into the software and do the calculation. Two things to remember is, one, you should do the osteotomy before you take the picture, because how we normally do it in a patient is, on the intact bone, we put on the frame, connect the deck fix, and then take out all the struts, saying that this is number 1, this is number 2, this is number 3, etc. Or once we put it on, you can just take out 2 of the struts on the convex side. Just take out 2 of the struts on the convex side and you will have enough space to do your osteotomy. Here you need to take out, you will have to do it with a hacksaw. But in real life we do it with drill bit and multiple, so just taking out 1 strut is usually good enough. And then put that strut back. If you have put your frame properly, it will come back into the right position before you take your picture. Okay? So first step is osteotomy, and then replace it in the right position. Then you have to photograph it. To photograph, we've paper. We've kept a couple of stations there where we've drawn this 100mm thing. And what you do is, one person stand above, directly above the bone model and take a picture, and the other guy at the same time with the measuring tape measures the source to film distance in millimeters. Now there are these papers that we have also distributed, which has all, on your tables, where you have to note the parameters. So there you can write down the source to film distance. Next. Now, you may take the pictures like this. What you should, when you are taking a picture, and this holds true for the X-ray also, what is important, you should be able to see all your struts, and you should be able to see the scaling object. Both of these things should be seen. In this particular thing, since we are doing the shaft, even if you don't see the ends, that's okay. But generally, I like to include the ends in that. So, same thing in X-ray. When patient goes to X-ray on a 14/17, it may not come. Then I take this, what's known as a kite view. I call it a kite view, whatever, oblique, so that I can see the upper and the lower joint also. And we take the picture, AP and lateral. Now you see there's a lot of other nonsense in that. So on your phone itself, you can rotate the image so that AP is up and down, lateral is also up and down, and crop it. So now you got only this much. This is important because if you have a lot of extraneous stuff, your zooming in, zooming out becomes difficult. So edit it on your phone and then shift it to your computer. Mark one as, put it into a folder, mark one as AP, mark one as lateral, so that when you come back to add it to the software, you're not confused about which is the AP and which is the lateral. So go back. So this is the important stuff. All 6 struts should be seen and your scaling object should be seen. Then you come, you do all your measurements. Where are the connectors, strut 1, strut 2, strut 3 on the fixed ring and the mobile ring? Whether there is a C extension by putting an arrow up or down. Don't try to do this on the model. Take it on a piece of paper, then it's easier to do it in the software, you won't make a mistake. And then the hash lengths, okay? Hash A and hash B on each strut, write it down. Once you have this paper, you can straight go to the software and enter it. So start a new case, you can call it, go a new case or whatever. Add your AP and lateral X-rays, add your numbers and then come up to the red line and then the schedule. And Divya and me are around. The Pinter boys are also there. Any questions, just call us. So now do your, disconnect one and do the osteotomy, then go and take the pictures. Before taking the picture, ठीक है. Now rotate it properly.
वो तो फोटो वो भी
हम ही शेयर कर देंगे.
हाँ, we can airdrop it to you.
You should be able to see it. You're able to see everything?
Yes.
Don't move. Okay. Hold it in AP. You're able to see that?
Yes.
And this can
Yes.
You may not sort of understand it fully, though I think you will, because you are all a bunch of guys who are doing Elizarov, and the fact that you have been able to do this easily shows that you have understood it well. So I'll show you this, okay? But it will be a relatively quicker exposition because I want to show you one more thing after this, and that is how to use it for metaphyseal deformities. How to use the joint line orientation, a slightly different way of planning on the same software. So, some of you all have got this. On day 1 itself, it's showing that it's going to reach a minimum limit or a maximum limit or a minimum limit on a particular day. Okay, may not be on the, it's not on the necessarily the first day, maybe the 5th day or the 6th day. Now, if you look at this, you will find that on, let's say, strut number 1, okay, what is the length of strut number 1? Is, I told you, A plus B, and that is 156 plus 46 there, right? And if you just show them on the software, actually the live software. Schedule page, na? Schedule ka? So there, go away, yeah, go away, so that it collapses first. On the upper left, there is this thing which says refer strut lengths. You don't need to remember the strut lengths. If you just keep it up there, keep your arrow up there, it will drop down and it shows you what is the minimum and maximum of hash A and hash B. And so a small acutely you can lengthen it. Hash B is which one? The one which you can acutely lengthen and shorten, right? So hash B has a travel of 24 millimeters, whereas the threaded portion has a travel of 20 millimeters, right? Same thing for medium and same for large. Each of them has their own ranges. So now go back to the presentation. So here, this is reaching the minimum limit. 156 plus 46 is how much? 202. Your maths is good, no? Then I'll believe you. Otherwise I have to do on the calculator. So minimum, okay? Now this is a medium, large strut. L, large strut. So large strut, hash A is 156. That means the minimum the threaded portion can go is 155, right? So it's just 1 millimeter away. Ek turn kiya, so it's going to reach its minimum. Because the threaded portion is the one that you can use to adjust. Hash B you can't use to, patient cannot use to adjust. So that means you want a total strut length of 202. And this strut is going what? Minus. So you need 202, out of which you should have as much threaded portion as possible. Now can we get that with a medium? If we keep, what is the minimum, what is the maximum strut length of a medium? 159 plus 52. Correct?
Yeah.
So that means if we put a medium strut with threaded portion of 159 and hash B of 52, you will get 50 millimeters of compression on that strut. Correct? So on day 1 itself, before the patient starts distraction, before the patient goes home, you can put in jacks, take out the large strut and put in a medium strut of the appropriate length. Right? So now you can go ahead. So same thing. Total length is 202. Maximum for that large is 246 plus 94. So, but this is reducing. Okay, go on. So, this is the same large strut. I'm not even changed from a large to a medium. This is the same large strut. What have I done? I have reduced the hash speed to 0 and I have maximized the hash A. So you see on the left and right, the total length is the same. But if you see the yellow arrow on the right side, you will see I have got that much now compression that is possible. That's all. I don't even need to change the strut in that particular. So each strut, you can look at the numbers that way and change the strut on day 1 itself. So your overall strut change during compression or distraction will not be required. Okay? The moment you take out a strut, this system becomes unstable. It requires all 6 struts to be on. The moment you take off one, it will become unstable. So whenever you want to change a strut, you put on a jack, just straight rods with coupled washers on one side or 2 sides, close to where that strut is attached. So here we are using a universal joint and coupled washers. When you are connecting 2 rings at an angle to each other, you can't have a straight rod. There has to be something to accommodate that angulation. So we are putting this in close to where that strut will be. So basically that connector we are stabilizing. We get that firm and stable. And now we can take out that particular strut. You can adjust it to the appropriate length and put it back. So that's adjusted, and total length is exactly the same, so nothing changes really speaking. And of course, once you've done that, take off the jack, otherwise you won't be able to get any correction. Okay, next. Now this is the other thing, that when you get in between the distraction phase, when the patient is distracting, you know that on such and such day this is going to reach a level 143 plus 46. This we have already changed. So we have to change it in the software also, right? Because we changed the numbers. So now we are changing those numbers, 202, no? 202 and 0. So we told the software now that yes, we have changed this strut, and now when we go back, nothing else we have changed, all the calculation and all is the same. Once we go back to the schedule, you will see that minimum limit has disappeared for that strut number 1. Now when you start doing this on a regular basis, you get a sense of, okay, this strut has to distract. So automatically when you put the strut on only, you will put it with maximum of hash B and minimum of hash A. And when a strut has to compress, you will require maximum of hash A and minimum of hash B within that combination, right? So that strut 1, that warning has gone away because now we have the right strut. Strut 1 and strut 6, both of them we had changed. So 2 warnings have gone. Now we've got only the max limit. These are medium struts and they reach their maximum it starts on the 20th of June. So probably on the 19th of June you can adjust this. One, just hold it, pause it there. strut limits is open. Go back a couple of frames. Yeah. A medium strut maximum is 159 and 52. Total length is how much? Same, what you said, no? 211 is the maximum length. Now what is the problem here? Why is it going to reach 161.25? Why does it say max? That means there must be more of hash B and less of hash A. What was the length of that? Just go back here and see. A plus B में होएगा देखो. Left arrow मारते जाओ. No, go back. Yeah, pull it behind. Okay. So B was only 2 in that. B ka you can't distract, right? So if you keep B maximum and A minimum, now go back to where you were. So why is it reaching that maximum is what you have to investigate. So this also on day 1 itself you can change the relative lengths of the strut. Go on. Right. So this is your final that you want to reach. So now if you want to change your struts, better to minimize the strut changes. Just play it at regular. Okay. So this is now, you want to change your struts so that 167 plus 44 will be around 211 से कम ही होएगा. तो इसमें अगर if you change the hash A and hash B's, you will have enough distraction. Next one, ना? और वीडियो हो गया कि नहीं इसका? No. You just need to tell the software that I have changed the length of the strut. That's all. Because the overall length we are keeping the same. Whatever was on that particular day. Now the next one, Divya. Okay. So strut 4 is 161. 159 is the maximum on a medium strut. So and that's an increasing strut. It's not going to go more on A. Alright. Strut 3 is total length is 160. So I can either put it to a large strut to meet that length. I told you no. Try and change all the struts at one time. So I want a total length of 170 and strut number 2 I want a total length of 171. I can get that by using a large strut. I can also do it with a medium strut. But medium strut means that I may need to change my strut once again. Right? Whereas if I change it to a large, till the end of distraction, I am not going to require any more change. And that happens sometimes, that when you start distraction, the length is so much. After it has gone a certain amount, then you need to change the strut. That initial length is too small to take a large, and the final length is too long for a medium. So that necessitates a strut change. Go on. So we get our numbers now. So here we are changing the struts just like we told you. We put the jack, and these are, what's that, 2, 3 and 4, na? So those are medium struts, and now we've got long struts of the same exact length ready from those numbers which I showed you, A plus B. This length is exactly the same, though one is large, one is medium. But the large one now has got enough distraction in it to last till the end. So one by one, we just change the struts. And notice that there is no real, force or any fiddling around too much. The jack keeps everything stable. But this is happening in the middle of the distraction period. This is not on day 1. So now on this particular day, I will have to go back and tell the software that, okay, I have now changed the struts. Go on. Next slide. So we started on the 12th of June and we are now on the 19th of June before it runs out. So there is a adjust. So when we click that adjust, it opens up another window. So 19th tak to distraction ho gaya. Now this is going to be a new distraction from the 20th, because on the 19th we are changing the struts. The distraction schedule will remain more or less the same. Only thing we will change is, yes, strut 2 from medium we will go to large. Change the strut parameter. So it will give you a warning that I understand that a change in strut overall length, but you are a expert orthopedic surgeon, so you are not going to change even more than 0.25 millimeters, right? 10 millimeters per the bar. So you click on that, same thing, it goes to large. You put in your new A and B to those numbers which we had written down. $55, 155 plus 16, total length, keep noticing, remains the same. This is almost 170, so 156 plus 14. This one is again 161. We change it to a large, total length is 161, 155 and 6. So we are not changing the total length, only thing we have changed relative. All these three numbers have changed. So then we have to tick that yes, I understand, and go ahead. Then you will see that it breaks over there. Click and make changes. So starting date for this new set of struts has become 20th June, but overall if you go down to the final A plus B, it will be exactly the same. So now you told the software this is what the way that it is distracting +3 or +2 or -1, whatever it is, that will remain the same. But we have told the software that I change the struts, right? So when you do it in the middle of distraction, this is how you adjust it. Okay? Next. So now there is no sort of markers left in that. But we have got ये क्या है अभी step 1 step next power. So that's the final correction using all of those numbers that we did. So all of you all, now when you all are you're reaching the strut maximum, this is what can be done. We won't do that for want of time, but at this point, one day before that, reaching the maximum, you will have changed these struts. Okay, and you guys, since you are getting many warnings right on day one itself, probably 2 or 3 of your struts you will be able to change. I told you we are distracting by 3 or 4 millimeters, so that's the maximum you will get. Now you've got how much was that distraction? 3 millimeters. And I want to be absolutely perfect, so I want to even compress that. So in this, there is a little bit of translation also, right? So in this, go next. So there is a option of add residual. So this is to finalize and finish up all your correction. So in the residual, so we will add residual there, and in that residual the numbers that we wanted, let's say 2 or 3 millimeters, we'll see how much we used over here. 2 or 3 millimeters to compensate for that, to avoid it from crashing. So translation on the AP, probably 2 millimeters or 1 millimeter to the left. Translation on the lateral, 2 millimeters to the left. Right. Okay. So 3 millimeters. Now you get 2 outlines. Actually 3 outlines. One is the yellow, which was the initial. Then you got the blue, which was the correction. And now you have the red that matches whatever the correction step 2 is also colored red, and therefore the outline is also colored red. Okay? And you can add a little bit of compression also probably. Okay? No, we've just added this translation. But if required, you can add that compression also. And then when you say add, go on. No, you need to click on add residual.
It's done.
Oh, okay.
So it creates 2 steps.
Now you've got step 1. So this is what we saw earlier. And if you click on step 2, you will get the next part. There. So step 2 will start after the end of the first schedule, and it will be total of, you look over there, it's 5 days. So in 5 days, whatever that small adjustment you have to do will happen. Now if it's 2-3 millimeters of translation only, I can use that feature where I can reduce the number of days. Instead of 5 days, I'll do it in 3 days. And we are going to the end now. Right. So now this is our final correction after the residual. So millimeter level adjustments if you want, you can do. Many a times it may not be necessary. It's not saying, I'm not saying that you should have your X-ray looking like this. And what I'm trying to say is, if you want to, you can always add or improve upon whatever it is that you have. Okay, next. Okay. So now is the second one for juxta articular deformities. So you can start on your same workshop thing. So you got the folder of distal femur. Create a new case and add the distal femur X-rays into that new case, and then we'll give you the numbers for that. वो एयरड्रॉप करना होता है PDF इसमें कहाँ से आता है एयरड्रॉप? एयरड्रॉप आईफोन MLB आगे चलेगा। हाँ आ गया। Then on that Akansha is it? नहीं ये भेजा क्या? ऊपर है एक लेफ्ट पे, आकांक्षा के ऊपर। You can load it into your system. I have the numbers here. I'll give it to everyone. These are 200 mm full rings. SFD in APN lateral is 680 millimeters. अच्छा आ गया, उसी में था क्या फोल्डर में? हाँ बस ठीक। So the numbers are in that folder only, PDF file. Sign in with your username and password only. The Netflix का username password. उस पे जाना, I'll tell you देखा, you can go to your screen, I'll tell you. But ये पिक्चर क्यों है इसमें? of the X-rays. SFD is 680 millimeters. AP scale is 100. Again 680, 100. Now remember, don't forget to put the yellow marker on and put the beam center. After putting in the numbers, adjust the marker, X-ray marker, put the beam center where? On the osteotomy. The osteotomy now is lower down.
So that you don't violate the rule. You don't fire from the head of the instrument.
Okay, X-ray beam center in the center of the osteotomy on both AP and lateral. Adjust the X-ray marker. Full rings of 200 millimeters, both of them. S1 is 3 and 54, 3 and 15, 24 and 15, 24 and 35, 43 and 35, 43 and 54. All are large struts. $176.0, $156.0, $164.0, $164.0, $225.0, $242.44, $203.4. Just keep this on the screen for a couple of minutes. Scroll up a little bit. Yeah, that's fine. You can take all the numbers from there instead of switching up and down. Right? You got the numbers? Okay, go on. You can. Now you know which is strut number 1? The blue one. That's the one. Divya will mark it for you on the AP and the lateral, and then you can take it from there. दोनों में पहले ये मार्क कर दे AP, सॉरी स्ट्रट 1. फाइन ट्यूनिंग बाद में कर सकते हैं. जस्ट दोनों दिखते हुए just put all the struts roughly and then fine tune for a while. They can see what you are. So that's strut 1. And then keep moving to the right. Strut 2, strut 3, strut 4. So now with this you should be able to come to the orange line step. The axis, because you had a diaphysis, so you could put those crosses and get a center line. Here, your distal femur is a bulbous thing. There's no way you can draw a particular axis. Oh, you may say that I can draw, my eyeballing is good, but you can't say for sure that that is going to be correct. So the way we do this is by, you can draw axes by a center line, or you can take a joint line. What is the LDFA? 87. Here we don't have a full length X-ray, so we'll have to use the anatomic LDFA. How much is the anatomic LDFA? 81, right? Mechanical axis to anatomic axis is between 5 to 7 degrees. So therefore anatomic LDFA is 81 degrees. So if I draw a line which is if I draw a line which is tangential to the femoral condyles, and from that line I draw an 81 degree line, what will I have? I will have the axis of the distal fragment. Correct? However, the two things to remember over there is, where does that line start from? The mechanical axis goes into the center of the knee. The anatomic axis starts on the medial side of the notch, not in the center of the notch. So two things you have to remember, the angle and where it starts from. So on the lateral, is there a deformity? Not really, right? So I am not going to correct anything in the lateral. I only want to correct in the AP. So the first, we are going to now draw the bone lines. The proximal, can you see the shaft? You can see the shaft. So proximal can be a shaft axis, the same as you drew before. Now don't do this yourself, just watch, because there are 2-3 things again here, intricate things which I am going to show you. What is the problem with juxta-articular deformities? What rule do you use? Rule 1 or rule 2? Rule 2. Why? Because usually the cora comes closer to the joint where you cannot do your osteotomy for anatomical reasons. So your osteotomy will be slightly higher, and therefore you will get some amount of translation depending on how high you do the osteotomy. So that's our proximal axis. Now let's draw the second axis is a joint. It looks the same, but just move the red one. No, the center red. Yeah. Look what happens when I move it. You have two angles over there, which was not there in the shaft axis. It's only there in the joint line. So therefore, we have to place this line now on the joint, the lower line. And where should this starting point be? On the medial aspect, right? So we just pull that slightly medial, little more, yeah, okay, and move that fellow till this shows 81 degrees. Till that shows 81 degrees. So now what is this distal thing? It's the joint line, and from the joint line we have derived the distal axis of the femur. In the earlier one, the two red points were coinciding. Here they are not coinciding. What does that mean? That it will create translation. And if you just extend that fellow, the green one, that's where the cora is. But the osteotomy is higher. Okay? So, go back. Now, this joint line, just show them the right click thing. When you right click this, every time you right click, it goes from half. Just one sec, let me. Hello? Hello? अभी गलत नंबर है वेंचर समझ वो जी एक फोन पे बात कर रहे हैं. So now it's in the center. You right click it once, it will go 1/3. So that's 1/3, 2/3. Right click it once more, it will go 1/5, 4/5. Where will you use all of this? Where is it 1/5, 4/5? For PPTA. If you want to use it for the proximal tibia in the lateral view, right? There the ratio is 1/5, 4/5. And 1/3, 2/3 कहाँ पे आता है? हाँ? किधर? हाँ. नहीं वो और ही होना चाहिए ना फिर. It has to come this side. Yeah. हाँ. No. I'm saying where do you use 1/3, 2/3? I can't remember anything where you use it directly. Yes. PDFA. PDFA. If you want to correct the PDFA, it is anterior 1/3 and posterior 2/3, right? But here we are not going to change it. So we'll keep it center, but we have moved it slightly to ensure that it is at the right starting point. Okay? Now come to the lateral. Do we want to change the lateral? We don't want to. But still, we have to mark the axis and tell the software that there is no deformity there. So we draw the proximal axis. and then draw the distal axis. Distal axis also I am going to use a shaft only, because I don't need to show any deformity. So I am just going to take this yellow line and put it, see over there, lateral is changing, so move it till it is 0. Yeah. So now I have closed the software, there is no deformity on the lateral, and I will move it front and back a little and get the yellow point at that appropriate level. So the software has been told in the lateral these two fragments are opposed to each other and there is no angulation between them. Structure at risk will be the most concave part. So we will put the structure there, and over here we will put it in the center, because there is no deformity over there. That's it. So now you will get angulation as well as translation, but this is going to clash. So when you want to do this, you have to distract it a little bit. Normally around 5-6 mm is what it takes to get it definitely off, and the same thing will happen over here. So the translation there was 11 millimeters, and that depends. The further away your osteotomy is from there, the more the translation you are going to get. Okay, and then you get the schedule. How much is the deformity? 18. So you must take about 20 days, 18-20 days, because 21, because we are also doing distraction. If you have not done the distraction, then you would just get it probably 18 or 19 days. Okay, and our struts are all long. We don't have any warning. Take them upar ja. Take it. No warnings. Right. So this is going to go straight forward. So now I want you to use this joint line method for the distal fragment on the AP, and then come to the schedule, see whether you are getting the same kind of schedule. And then finally we have what rotation we have to show.
What difference will be there if you have certain lateral?
Sorry?
What difference will it be there when you have certain lateral?
If you have to correct the lateral, go back. Let us say that there is a procurvator. Okay, so for procurvator you need to have the PDFA. Okay, PDFA is normally 84. And where is the PDFA? The PDFA is where the epiphyseal scar was, which is here. Okay, little lower on the front there. And you keep cycling through it till you come to one more. Yeah. So that's 1/3, 2/3. Alright. Now if you do your, so because this is normal, you see it's more or less parallel. But just say for argument's sake that this was abnormal, change that. You want to give it, this is a polio patient, you want to do a recurvatum osteotomy. No, that one is too high. When you are checking PDFA, it relates to the anatomic axis of the distal third femur. So you have to come right down here. Even the upper one should come lower. Yeah. वो मैंने तेरे को गलत बोला, फिर वो ऊपर कर, आगे वाला ऊपर कर और पीछे पीछे वाला भी नहीं ना, पीछे वाला और अभी 84 पर। So on this you can't make out the PDF. On the X-ray you will be able to. Now let us say that you want to create a recurvatum over here. So Divya just change that angle to 2 more. No, the other way now. This is. It will create procurvatum. You go the other way. This is fine. This is fine. The distal axis change it the other way. Okay. Yeah. All right. Now this is a number. Let us say I want to create recurvatum in a polio patient. Go. So the distal fragment will change accordingly. AP will remain the same, but the distal will change in the lateral. Yes. Take a 5/8 ring and place it on a full ring of the same size.
One end is 0.
No. But that is if you keep one end as 0. But when you suppose you have a 5/8 ring like this.
Take as a 0. You don't need to.
Okay. In the
Sure, it takes that.
one end you take as 0 and then count the other way. The back end. Take it as 0 and count from there. Because we are counting to the right, no? So the empty part के बाद जो hole है, take that as 0 and then come here. Or the other way is you put the 5/8 on the full ring. So this will correspond to 0. और full ring के हिसाब से numbers count करो, तो भी वो होगा. लेकिन software में you will have to put it as a full ring. If you say 5/8 ring, the software will say, okay, this is how he has counted. No, the posterior edge. Because you are counting to the right. You get the point, no? ये ऐसा है रिंग. I am the patient. Okay? तो ये रिंग ऐसे आएगा. So you will count to the right. तो इसको 0 काउंट करोगे तो ये क्या होगा? You don't know how many holes are in. लेकिन इसको 0 काउंट करोगे तो 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, ऐसे. From the back. But I have hardly used 5/8 rings. Meaning, there's no reason to use a 5/8 ring. Theoretically, it allows movement, blah blah blah. But using a full ring, the moment the rings are out, movement is good. हाँ, ये 5/8 नहीं है ना, ये half ही है, हाँ. हाँ, mid shaft, yes. Mid shaft, yes. Then you can use it.
Then anterior.
How?
The empty space is medial. With anterior.
Then you will count this way. For the left leg, for the right leg, it will be the back one. Now do it. Add rotation. Again, very intuitive. हाँ ये बता दो. And just to underline, somebody asked me, no? Who asked me? I think you asked me. How do you put the shan spins and all that? This is the answer to that. What we are showing you right now is only a demo, a workshop demo. This is not how you will put on an Elizarov for the patient. Patient ke liye Elizarov will be exactly as what is required. Like this is a mid-shaft deformity. We put on two rings, wires, shan spins as the situation dictates. ऐसा नहीं है कि डेप्थ फिक्स लगाओ तो थोड़ा कम फिक्सेशन लगेगा ना. If your fixation on the bone is not stable, the depth fix will move the rings, but the rings will not move the bone. So the only difference between these two is between the mobile segment, instead of hinges, we have rings. Now this is mid shaft. अगर metaphyseal हुआ तो we will have only one ring on that, but multiple levels of fixation. I am talking on that, how not to span the joint tomorrow. So that's what is the role of 6-axis. Okay. And its most important role is in rotation. Which is pretty difficult with the Elizarov. So rest of it is as you did it. But rotation can only be recognized clinically. That is in a prone position, thigh-foot axis, 1. 2, if it's in the tibia. In the femur you will not find out with that. And 2 is with a CT scan. So out of everything, I think CT scan is probably the best way to do it. Again, as in everything that we have said, all your activities happen as if the patient is facing you. So you face the patient and decide in which direction you want the foot to go. So on the left side there, that patient has got an internal rotation deformity. So you want the foot to go that side. Same happens for the left foot of a patient with an external rotation deformity. You want the foot to go that side. That's all you need to remember. And so to correct external rotation of the right side or internal rotation of the left side, you will move it this way. To correct that internal rotation which I just pointed out to you on the right side, or external rotation. So you don't need to get caught into what deformity. Look at it, where do I want the foot to go, and that will tell you which arrow you need to click. Go on. So here is that rotation ring which we skipped in the earlier thing. Now this guy has what deformity you think? We have every time you click that arrow it goes 15, and this is the right leg. So what deformity do you think this patient had? I am moving the foot this way. So I am correcting an external rotation deformity, right? Go on. So you just, same thing, you add the number of so many degrees or keep clicking that arrow till it comes to the desired number. So to correct this deformity, I mean both of these, one in the left and one in the right, the software is not looking external, internal, left, right. It only knows which direction you want to move. So for both of these, you will click on that left side wala arrow in as many degrees as you want. Every time you click, it will go 1. So tick, 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 tick. You can do it 15 times. It will give you 15 degrees of correction to the left in both of these situations. Go on. And if you want to correct this, then you click on that arrow. Go on. So this guy, so this when there is a combination of angulation as well as rotation, then the 6-axis really comes into its own. There is nothing that can, regular Elizarov also cannot really beat it. Go on. So that's his X-rays. lateral is fine. You can see when his feet are together, the patella is facing inwards. And with the thigh foot axis, you can make out that there is a rotational deformity. Next. So when we start with a regular Ilizarov with hinges. And I always like to keep the center bolts aligned. So the center bolts are aligned. Go on. Then we start distraction. Or did we put we put a left fix for a straight away. Alright. So
rotation.
yeah. Okay, next. So here now we have corrected. This is that step that we get, but there we added the rotation. In addition to all the angulation, etc., we added the rotation. Okay, next. And lengthening of, yeah, 5. So that's the day 7, 14 days. So now you see the center bolts. They have, the lower one has gone internally. Next. 14 days of correction. Is our angulation proper? Yes. That's confirmed on the X-rays. And then we do a 5 millimeter compression. Go back. You see the 6 over there? That's the beam center. So when the X-ray technician takes the X-ray, wherever the crossing comes, he places this numeral 6. So that's how we know that that is the beam center. Now that may not be in the middle of the osteotomy, but we know where the beam center is approximately. And you can see the amount of rotation that has occurred. And once we've got it right, we convert it to straight rods. Their fix can go for another patient. This is very useful, especially for you guys, in public hospitals, where it's not easy to change the hardware time to time. So you put on the depth fix, get your correction, then put the straight rods. Then it takes whatever time to heal in terms of the Ilizarov, but the correction becomes much easier. Raju, they have it for how many days? 5 days?
We can give it for about 1 week or 10 days.
1 week. So you'll have this software for a week. We'll send you X-rays, epilateral pictures, which you can do on your own at home, just like we send you this folder. So we can send you folders of X-rays, and we have, if you're already using DevFix, then there is a devfix.problems@gmail.com. You can send it over there. We have access. You can share that case there. So we have access to that, and then we can look at what is the problem. But usually, as I already told you, if the orange lines are not matching, 99 times out of 100, that's the only reason. That is that your data there's something wrong with your data. Okay. Anything else? That's it. हाँ? QR कोड है क्या? किसका QR कोड? वो DevFix का कि Ilizarov इंटरैक्टिव. वो मैं तेरे को भेजता हूँ वो. Those of you who are not on this can always. So you can take a picture of this. This is a Ilizarov interactive education sort of, where you can put in your cases, we can discuss it, blah blah blah. There are many others, Ilizarov users also on the group. This is not necessarily just DevFix. It's for everything related to Ilizarov. And we put a code on the common Asamicon group also. Content of the course, वो एक scan भी था ना उसमें, one of the lectures you had a scan me. वो डाउनलोड मत कर, वो वाला कर, 49 वाला कर, डोंट डाउनलोड. इसमें क्या है, HDMI है ना. हाँ नहीं, टाइप सी नहीं, HDMI है कि नहीं. हाँ तो उसमें डाल सकते हैं. ये लगा इधर है इसका HDMI. I think this is it. Just check. This is a link to the videos that we have on YouTube. जा रहा है ना YouTube को? जा रहा है? हाँ. So all these videos which we showed you now, they are there with